I'm Sihao from Southeast University in China, and I'm very glad to share our work with you today. And let me introduce it. Our title is Information Representation and Automatic Matching in Building Regulations and BIM. And as you know, BIM models are widely used in our civil engineering, but there are many errors in the creation and the modification and the conversion in this work process. So in China, the traditional method to check the BIM models is by human checking. I think it's inefficient. So for governments, maybe there are many paper documents and complex review process and human involvement and regulatory difficulties. And for designers, maybe there are some profession contradictions and long design cycle and high error rate and inefficient. And for construction managers, maybe there are non-interoperability of data and building deviations and rework costs. So the purpose and the significations of our study are as follows. First, we want to establish a universal approach for automated continuous checking of BIM models, and we want to convert complex and ambiguous specifications into machine-readable rules. And then we want to map model data and rule data into the same space for matching and validation. And the last one is we want to develop an ecosystem of integrated functional modules based on the open BIM environment. So this is our workflow. Okay. Oh, sorry. Oh, this is our workflow. First, we use the maybe Auto CD and Revit. We can to create the geometric models, and then we added some information to this model to become it a rich information model, and then it converted into the IFC fields. So, and we designed some Dynamo components to extract the information and become it into triplet formats. And then the second way is we use some database and some manually work to construct our ontology, and then give this ontology with some Chinese regulations to construct knowledge graph. And then by some cipher statements, we can obtain some graph triplets. And then the graph triplets is the same as the triplet information, so they can be matched. And lastly, we development platform to do this BIM model checking, and the graph and the BIM model can be uploaded into this platform, and then in this on this platform we can check it and match it, and as a result we can get the output results. It's a checking report, and the components with some errors can be highlighted on the platform, the right circle. And this is our data flow from the CAD draws, and we can draw the Revit models, and with some rich information such as carbon and such as fire protection rules. Yeah, we can get a rich information model, and then we designed many this follows Dynamo components, many for doors, for windows, and some others, so we can extract the information from these BIM models. For the rule construction, we use the Stanford seven-step method to construct our knowledge graph, and this is some Chinese building rules, and for fire protection and building regulations and some others. And for common terms, we use Building Smart BSDD. It's a library to make the graph more common. And so we can got some graph node. This graph is part of the whole knowledge graph. And this is a data metric summary. In order to validate our method, we conducted experiment in a Chinese community health center, and there are maybe 5,000 components in this model. And this is an example for our rule construction. Dependency syntactic is one of the key knowledge technology in NLP, which is used to identify the dependence relationships between words in a sentence. This is an example. Balcony should set up protective railing. So it was converted to this format. And we designed 7 tabs. As you like, you can design more tabs, and in future research, we can design more tabs to make it more rich. And we, based on the WebGL, we designed our platform for BIM model checking, and including application server and database server, and web server, and some cleans. This is a video. Sorry, it's for Chinese. So the UI is Chinese, but I can explain it. We design the graph, and we upload the BIM models. We can check the BIM models on the platform, and we choose the regulation, which regulation you want, and finally it will be matched automatically, and then we can. Yeah, it's matching. Then we can go the output. The highlight is the arrow. The arrow information in the BIM model with the regulations, and we can download the report. Yeah, Chinese report. So finally, our results, the uploaded BIM model, the user upload his BIM models, and he choose what regulations he wants, and the platform will automatically match them and then give you a report. Yeah, that's all. Thank you for listening.